Hello, Precalculus students. Today's notes are on linear models and scatter plots. This is section 1-7 in your textbook. And first example says construct a scatter plot of the following data. And we've got some heights in inches and shoe sizes. So we assume that this means these are heights of different students here and their shoe sizes. So someone who's 68 inches tall has a shoe size of 10. Okay, so to make a scatter plot, we need to first define our variables and think of the height as your x, think of shoe size as your y. Height is your independent variable. Your shoe size depends on your height. So let's plot this data here. So I've got a couple axes, and I'm going to put height down here along my x-axis and shoe size here on the y-axis. Okay, so for heights, we could start at 0, go all the way up, but the lowest height we have up here is 57 inches. So I'm going to skip to maybe, let's start at 50, and then I'll get 55, let's say 60, 65. I think we go up to 70. I think that'll take care of everybody. And then shoe sizes, again, we could start at 0, go up to 10, but I'm going to skip some, and let's start at 6. And from there we can go up to 10. Okay, perfect. So I'm going to switch colors here for my points. So I want to get a point at 68, 10. So I'm going to, we're pretty good. We know how to plot points. So let me see if I can get these points here. 61, 8. 57, 6. Let's go 60 and 7. 58 and 7. 66 and 9. 65 and 9. And 58 and 8. So I think there's all of my points. So there's our scatter plot. One thing I should have on here is a title. So we might talk about something like shoe size and height. Something along those lines. So a few things that we should have, and I'm going to put inches here. Make sure you have labels. Make sure you have an appropriate scale. Scale should go up by the same amount every time. And make sure you have a title. Okay, so that's our scatter plot, and I think we can handle making those scatter plots. Now, I do want to talk about some terminology, however. So let's say you have a scatter plot that kind of goes in this direction, kind of goes upward. We say that anything that in general goes upward has a positive correlation. Anything that in general goes downward has a negative correlation. And sometimes you'll see data that just doesn't make any sense. It's kind of just all over the place. You might say this has no correlation. Now, data can have a positive or negative correlation. It can also have a linear correlation where things are going up just in a straight line in general. Notice it doesn't have to be in a perfect straight line to have a linear correlation. If you see some other pattern going on, but it's just not following a straight line, you might say it has a non-linear correlation. So data could have, like, for example, this has a positive linear correlation. This one looks like a negative linear. This is a positive nonlinear correlation. So we can usually use a couple different words to describe a correlation between some points. Okay. Third example, though, it says use a calculator to graph a scatter plot of the data and find the best fit line through the data. So remember that data we had in example 1? This is saying use a calculator to graph that scatter plot and then find the equation of the line that fits the best through that data. So I'm going to go back to that first example. We want the equation of a line that comes closest to going right through these points. Now, you'll never find a line that perfectly fits these points, but you want to find one that goes through as best as we can. So I'm going to grab my calculator here. Let's put this aside. Let's grab that calculator. There it is. I'm just going to move some things over here. There we go. And there we go. So how do we do this? Well, the first thing we want to do is on your calculator, press your stat key. And first option there says edit. So I'm going to press enter. I want to put this data into these two lists. Now, if you ever have stuff in your data in your lists that need to be cleared, press your up arrow, press the clear key, and when you press down, all that data is gone. So I'm going to put the heights in list 1. So let me type all these heights in here. And you can probably type this faster than I can, but I'm going to get this in here as quickly as I can. Okay, I think I've got them all. And then I'm going to put all the shoe sizes in list 2. Okay, now this is paired data, so every number in list 1 must match up with the numbers in list 2. All right, now first of all, how do we make a scatter plot here? So if we look above your y equals key, it says stat plot. So if you press second and go to the stat plot menu, what we need to do is turn one of these plots on. So I'm going to press enter, and I want to highlight the word on and press enter again. Now keep that in mind. When you're done with this, you might want to turn them off so we can see our regular graphs again. But this will allow us to see any of these different kinds of graphs. We want that first type. Our data is in list 1 and list 2, and I like these open circles for a mark. But if you need to change anything, you can press your up-down arrow and make those changes. Once everything is set, if you press your zoom key, the 9th choice in this menu is zoom stat. It'll zoom in on your statistics. And if you do that, there is a scatter plot of what we just graphed before. So same exact kind of graph. We just made it on our calculator now. Now the advantage of doing it on your calculator is that your calculator can give you some additional information as well. So back to the calculator here, if you press your stat key and go over to the word calc. Now there's a whole bunch of different things we can calculate. What we want is the equation of the best fitting line. That's this 4th option, linear regression. So I'm going to go down here to that 4th option, press enter. Linear regression, it'll give us an equation in the form like y equals mx plus b or ax plus b. I'm going to type in here second 1, comma, second 2. So it's like saying find the regression equation of the line using the data in list 1 and list 2. Now you don't even have to type that in if your data is in list 1, list 2. Those are like the default lists. But if you have your data somewhere else, you must type that in there. If I press enter, it tells me, and I'm going to pull this on this screen as well, it tells me that the equation is y equals 0.29x plus negative 9.70. So it gives you AB, which stands for your slope, and y-intercept. So we can plug those decimals into this equation, y equals mx plus b. Okay, so now that we've done that, I'm going to put my calculator aside, and let's go to, so we took care of this. Let's go to this 4th and final example. Use the linear model to predict the shoe size of someone who is 70 inches tall. Well, here's the model we had. Y equals 0.29x plus negative 9.7. Now y stood for the, let's see, what was that shoe size? So I'm going to label that variable. X stood for the height. So now we can plug 70 inches in place of x. So I can say shoe size equals 0.29 times 70 plus negative 9.7. And if we calculate that, you'll see that y is about equal to 10.6, which if we look at the shoe sizes we had before, we could say, hey, that's a size of, you might say 10.5, or you might say that's a shoe size of 11. How you round it really isn't as important in this example. Okay, but the key to remember, scatter plot means a graph comparing x and y, and your calculator can be a useful tool in making both scatter plots and finding these equations of the best fit line through your data. All right, that wraps up your notes, relatively brief notes. Homework on page 78. Check out these odd problems there. See if you can get some practice making these scatter plots by hand and on your calculator.